Hello, you are viewing narrated PowerPoint lectures for Module 7 Part 2. We will continue discussing non-Mendelian inheritance patterns. In the previous segment, we were talking about how sex and sex-linked and sex-influenced traits are inherited. Let us continue. We left off with this slide in the previous segment. This slide shows an example of a Punnett square and a monohybrid cross involving an X-linked recessive allele. Red-green colorblindness is an example of a sex-linked trait. Colorblindness is caused by recessive alleles on either of the two genes located on the X chromosome. The normal dominant alleles of these genes, called B in this example, encode proteins that allow one set of eye cones to be most sensitive to red light and another to be most sensitive to green light. There are several defective recessive alleles of these genes designated by the lowercase b. The afflicted person cannot distinguish between red and green colors. In terms of X-linked recessive alleles and colorblindness, a man can have the genotype of the normal allele for seeing red and green colors on his Y chromosome, or he can have the mutant defective allele on his Y chromosome. This means that he has colorblindness, or the color vision allele B or B on his X chromosome and no corresponding gene on his Y chromosome. He will have normal color vision if his X chromosome bears the dominant normal version of the allele, or he will be colorblind if his X chromosome bears the lowercase mutant version of the allele. Note that with X-linked recessive alleles, men either have the disorder or they don't. They cannot be carriers. On the other hand, a woman may be homozygous dominant and be completely normal and not have color blindness. She can be a heterozygous, which means she's a carrier for the colorblind allele, but she has normal color vision, or she can actually be colorblind. Because women have two X chromosomes that can each carry an allele for the trait, they can only be colorblind if they inherit two copies of the mutated allele, one on each X chromosome. A colorblind man will pass his defective allele only to his daughters because only his daughters inherit his X chromosome. On the other hand, a heterozygous woman can pass her defective allele to have her sons who will be colorblind. So colorblind daughters can arise if the man passes the colorblind allele to his daughter, and colorblind sons can arise if the woman passes a colorblind allele to her sons. In this example, we have a woman who is normal vision, but she's a carrier, mating with a male who is completely normal. In this example, what happens is you have 50% of the daughters will be completely normal, non-carriers. 50% of the daughters will be carriers. Then in terms of the sons, 50% of the sons will be colorblind and 50% chance of the sons having normal vision. Remember, with the X-linked recessive allele disorders, women can be completely normal, can be normal but a carrier, or can have the disease. However, men, there's no in between. Men either are completely normal, non-carriers, or they have the full-blown disease. There are several types of X-linked recessive disorders that occur in humans. Some examples are colorblindness, muscular dystrophy, and hemophilia. Not being able to distinguish the color red from the color green is a form of colorblindness that is sex-linked. The colorblindness gene is recessive and located on the X chromosome. And this slide shows you a color pattern that someone with normal color vision would see, and then how this same pattern would look to someone who has red-green colorblindness. Muscular dystrophy is another one of these X-linked disorders. Muscular dystrophy is a group of muscle diseases that weaken the musculoskeletal system and hamper locomotion. Muscular dystrophies are characterized by progressive skeletal muscle weakness, defects in muscle proteins, and the death of muscle cells and tissues. Duchenne and Becker muscular dystrophies, being caused by a mutation of a gene located on the X chromosome, predominantly affect males, although females can sometimes have it. Most types of muscular dystrophy are multi-system disorders with manifestations in body systems, including the heart, GI system, nervous system, endocrine system, eyes, and the brain. So in addition to being X-linked inheritance pattern, muscular dystrophy also exhibits pleiotropy in that it affects a large number of different systems within an organism from a single type of mutation. Hemophilia is a bleeding disorder that slows down the blood clotting process. People who have hemophilia often have longer bleeding after an injury or surgery. People who have severe hemophilia have spontaneous bleeding in the joints and muscles. Hemophilia occurs more commonly in males than in females. The most common types of hemophilia are hemophilia A and hemophilia B. People who have hemophilia A have low levels of a blood clotting factor called factor VIII. People who have hemophilia B have low levels of factor IX. The two types of hemophilia are caused by permanent gene mutations in different genes. Hemophilia is inherited in an X-linked recessive pattern. A condition is considered X-linked when the gene mutation that causes it is located on the X chromosome, one of the two sex chromosomes. In males who have only one X chromosome, remember, one altered copy of the gene in each cell is enough to cause the disease. Since females have two X chromosomes, a mutation must be present in both copies of the gene to cause the hemophilia. So once again, with these X-linked recessive disorders, men are affected at a greater rate than females. Since men have only one X chromosome, if the gene is defective on that X chromosome, there is no other chromosome to back it up. A major characteristic of X-linked inheritance is that fathers cannot pass X-linked traits to their sons, but they can pass them to their daughters. On the other hand, women can pass X-linked disorders to their sons. This slide shows an example of hemophilia in European royal families. There was a period of time where it was believed that you should have children with close relatives in order to keep the bloodline pure. Royal families did this quite often. Unfortunately, when you have children with blood relatives, you increase the likelihood that certain recessive mutations will come out. Because if you have these recessive mutations in your gene pool, the likelihood that a close relative will have them in their gene pool as well is high. So if you notice in this pedigree chart, the hemophilia disorder became more and more common with each generation, probably because they were marrying close relatives. The last thing we'll talk about for this narrated PowerPoint lecture is something called sex-influenced inheritance. This is different from X-linked inheritance. Sex-influenced traits are actually not on the sex chromosomes. Their genes are located on the autosomes. What makes these traits unusual is the way they are expressed phenotypically. In this case, in the case of sex-influenced inheritance, the difference is in the way the two genders express the genes. One classic example of a sex-influenced trait is pattern baldness in humans, sometimes called male pattern baldness, although the condition isn't restricted to males. The gene has two alleles, the bald and the non-bald gene allele. The behaviors of these products of these genes are highly influenced by the hormones in the individual, particularly by the hormone testosterone. In the presence of high levels of testosterone, the baldness allele has a very powerful influence. In the presence of low levels of testosterone, this allele is quite ineffectual. All humans have testosterone, but males have much higher levels of this hormone than females do. The result is that in males, the baldness allele behaves like a dominant allele, while in females it behaves like a recessive allele. As in all cases, dominance only matters in the heterozygotes, so this means that heterozygous males will experience hair loss and heterozygous females will not. Even homozygous females may experience no more than a thinning of the hair, but may develop bald spots or have receding hairlines. So with sex-influenced inheritance, the way in which the trait expresses itself phenotypically is influenced by whether you're male or female. In the case of pattern baldness, you can inherit the mutation for being bald. However, if you are female, most likely you will experience nothing more than thinning of the hair. However, if you're male, you most likely will experience male pattern baldness. This concludes our set of narrated PowerPoint lectures for Module 7, Part 2.